Okay, college algebra students, this is the review for the Unit 3 test. I'm going to be writing with a pen on the screen, so it's not going to look great, but we'll get there. On number 1 for both A and B, we're asked to find the vertex, the axis of symmetry, tell if it opens up or down, and sketch a graph. So we have two parabolas here. Remember that our general form is a x minus h squared plus k, where h and k are the x and y of our vertex. So basically on both these problems, we can just extract out the vertex. Now realize, remember, it's x minus h, so that means that since that says plus 3, that's going to be a negative 3. This one I don't change the sign though, just negative 4. So my vertex is negative 3, negative 4. The axis of symmetry is very simple. Remember, it's a vertical line, so that's going to be of the form x equals a number, and it's just going through the x coordinate of the vertex, so it's x equals negative 3. Remember that the axis of symmetry is x equals that, not just the number negative 3. Does it open up or down? Well, that's just if it's positive or negative out in front. Since that's a positive 2, this is going to open up. And now we have enough information to sketch a graph. So I'm going to do these on a separate window, just so we can actually see what's happening. So my vertex was at negative 3, negative 4. So negative 3, negative 4. I know it opens up. Now, if you want to plot some more points to it, since there was a 2 out in front of all that other stuff, that means a vertical stretch of 2, if we remember that from the last unit. So I'm going to have 2 more dots up there, which is going to cause a slight vertical stretch. Again, my graphs are not going to look great, but it'll look something like that. Opening up is kind of the key there, and the vertex in the correct place. We do not have to graph the axis of symmetry, but x equals negative 3 would put that axis of symmetry going right down there. It's actually kind of hard to see, so let's do it this way. There we go. There's our axis of symmetry. On letter B, my vertex is, well, let's see. Remember, we switched this sign, so that's going to be 5, comma. There's nothing out here, but that's just a 0, so 5, comma 0. I'm adding nothing on the end. Again, remember the axis of symmetry is always x equals, and it's just the x coordinate of that vertex, 5. And since this one has a negative out in front of it, this one will open down. So for a quick sketch of this one, get all this out of here. Our vertex is at 5, 0. We're opening down. This one was did not have a stretch or anything on it, so your next 2 points be right there. And then we build our parabola off of that. And again, you don't have to draw the axis of symmetry, but x equals 5 would be this vertical line that splits the parabola in half. On number 2, this is just a synthetic division problem. So remember, you can only use synthetic division when you're dividing by a linear divisor. So x minus 2, remember that means I switch the sign on that, and I'm going to synthetically divide by +2. Remember to check that your powers decrease by increments of 1, and they do on this one. I go 4, 3, 2, 1, none. So I don't need to put any zeros in there. There's no placeholders needed. So I'm just going to list my coefficients: 4, -12, 10, -7, and my constant 6. And remember, I start off by dropping down the first number. So that's going to be a 4. And then I'm going to multiply the divisor 2 by the 4. That'll give me 8. Add these two together, -4. Repeat the process. Add these two together, multiply, add these two together, multiply, and lo and behold, I get a remainder of 0 on this one. Remember that when you're doing synthetic division, basically your dividend is going to decrease by 1 degree. So that was x to the 4th. So that means that my quotient, my answer here, is going to start with x to the 3rd. And then I just keep reducing by 1 power. And now it doesn't necessarily mean that anytime I do a synthetic division problem that I'm going to get a remainder of 0, but that does on this problem mean that x minus 2 actually is a factor of that 4x to the 4th item. On number 3, we're going to use the remainder theorem to find f of k. So I do not switch the sign on this because it's just giving me the number k. So I'm going to synthetically divide again. Now notice on this one that my powers go 3, 1. So I skip over the x squared term, which means I have to put in a 0 there. So this is going to be 3, 0, -7, 2. And then I follow that same process, drop down the first number, then it's multiply and add. Multiply, add. Multiply, oops, I was thinking of the answer there, sorry about that. Multiply, add. Remember, the remainder theorem stated that the remainder is what f of k would equal. So this is saying that f of -2 should equal -8. Now, this is one way to do it. This is technically using the remainder theorem. Another way you could do this is you could, so here's another option, you could plug -2 in for x. So this would be 3 times -2 to the 3rd minus 7 times -2 plus 2. You should get -8 out of this. Remember, PEMDAS says we have to do the exponents first, so this would be -8 times 3 plus 14 plus 2. If you solve all that out, you get the same -8. So either way you want to think of it, these are synonymous with each other. Finding the remainder when you divide, plugging the number in, same thing. Basically the same concept on number 4, except that we're taking it one step further. We're going to use the factor theorem, which basically says if it gives me 0 for a remainder, then it's a factor. So remember now on this one, though, it's giving me the actual linear divisor, which is x plus 4. So that means I have to switch the sign to -4. Note that my powers do not decrease by 1 every time. I go 3, 2. There is no x to the 1st. So there's going to have to be a placeholder in there. So -2, 7, 0, 2. And I'll run through the process pretty fast here. And actually, I start to get some nasty numbers on this one. And somewhat gross. I end up with 242. So first thing to answer the question, to decide if that is a factor, no, it's not. I should have got a remainder of 0. I did not. I got a remainder of 242. So no, because you could say the remainder is 242. I believe on your test, you're going to write because f of -4 is 242. Again, it should have equaled 0 if it was a factor, but it did not. I'm not going to go through the process, but again, another option is to take that -4 and plug it in for x. So again, kind of like I did on the previous problem, I could have separated this, plug in -4, I would have seen that I did not get 0, I get 242. On number 5, this time it wants us to write this in linear factors, given that -7 is a 0. Okay, so again, if it's telling me the 0, I don't have to switch the sign, but I can synthetically divide. It's saying that dividing by -7 should get me a remainder of 0. I check my powers. They are decreasing by 1. 3, 2, 1, none. So I don't have to insert any placeholder zeros. Go through my synthetic division. Again, I should be getting a remainder of 0. If you don't, redo the problem. You did something wrong. It's telling me it's a 0. And as I roll through, yes, I do indeed get 0. Perfect. So that's a start to this. Now, the key here is that I've taken this from degree 3 down to degree 2. So this is 2x squared minus 7x plus 6. Oops. I need to factor this. Now, this goes back to the factoring we've been doing since the beginning of the semester. We had several different methods. If you had my class, I taught you X box factoring, maybe you guess and check, factor by grouping, several options. But this quadratic here factors into 2x minus 3, x minus 2. And remember, you could check to make sure that works by using FOIL. If you FOIL that, it should get you back to this one. Now, here's where you got to be careful, and you'll mess up the problem and get a -5 on the test. Remember that -7 is also a 0. That means that there is also a factor of x plus 7. Remember, you have to switch that sign because if you plugged in -7, that would make it 0. So do not forget about the easy part, which was if I give you a 0, basically x minus that number, which turned into x plus 7, is a factor. So my solution on number 5, 2x minus 3, x minus 2, x plus 7. If you want to check it, you can multiply all of that back out. You'd have to do a lot of distributing, but it should get you right back to where we started. Remember, factoring doesn't change the problem, it just changed the look of it. On number 6, we want to sketch a rough graph. And let me actually make my graph a little bigger here of this function. Okay, so here's how I would attack this. I'm going to figure out the zeros, and I'm going to figure out their multiplicity. And basically on their multiplicity, I'm just going to worry about if it's even or odd. So my first 0 would be whatever makes the factor of x equal 0. Well, that's simple enough. That's just 0. That x is raised to the first power, so that it has an odd multiplicity. And the key there really is that that means it's going to cross through the x-axis. So I know at 0 on my graph here, the graph will cross through. My next factor is x minus 2. The 0 for that would be positive 2. That is raised to the first power. Remember, the multiplicity is how often the factor exists, not if the numbers even or odd. That doesn't matter. So this is raised to the first, which is odd, which again means we're going to cross there. So at 2 on my graph, I know I'm going to hit the x-axis, and I know my graph's going to cross through there. My last factor is x plus 4. So the 0 there would be negative 4. That is raised to the second power, so that's got an even multiplicity, which means it's going to bounce or ricochet off. So I know at negative 4, I'm going to hit the x-axis, but I'm going to bounce off. I'm not going to slice through. Now, to figure out what the graph actually looks like, without actually multiplying all of this stuff out, I know that at the beginning, I would have an x squared there, another x, and another x. If this was all multiplied out, I know the beginning would be x times x times x squared. That's x to the 4th. And then there'd be other stuff. But I don't care about that other stuff. I'm just trying to figure out the end behavior here. My leading term, my highest degree term, has an even power, which tells me I'm going in the same direction, and it's positive. This means it's going to be high to the left and high to the right. So what does that mean for my graph? I'm starting up high. I'm going to bounce off at negative 4. I'm going to cross through at 0. I'm going to cross through at 2. And I can tell that I also end up high. All right, I'm going to stop this video, and I'll make a second video for the remainder of this review.